For this problem, we need to, given the graph, find the values of x in which the function is concave down, and also for when the values are concave up. We also need to find the x values of the points of inflection. So when something is concave down, we're going to have some kind of curve. It can be like this, right? Where it's facing downwards. That's really the big hint right here. When it's facing down, and then we're going to draw three arrows, one going in like this, one going in like this, and one going in like this. And so this is where we have concavity where it's downwards. So from this point to this point, it's concave down. Now concave up is exactly the opposite. So where we have something that looks like this, we can draw a point right here and a point right here. And we'll have these three arrows like this, where it is concave up. Now, to further go on with this, when we look at concavity, we're really looking at the slope. And to find slope, we would take derivative. Since we're not given a function here, we're not taking any derivatives, we're just looking at the graph. But the derivative would be going from a positive, so we would have a slope going up like this. It would zero out, and then it would go negative. So we would have a positive, 0 to negative slope. Now for concave up, we would also be looking at the slope. We have it going from a negative to a zeroed out slope into a positive slope. So we can see that these are really just backwards. Now we can look at our graph. So what is concave down? Well, this graph looks like we can draw these arrows in like this. And it is from here to here where this happens. And so this is concave down. And that means that the points from -10 to -6 are concave down. Now, the next part, we can see we have arrows going up like this, this, and like this. And so that means that from the same point right here to this point right here, we are going to have concave up. So from -6 to 0, we have concave up. Now, let's go a little bit more into detail, looking at the first concave down. We can see that the slope is going in the positive direction. It then zeroes out right here, and then it goes in the negative direction. So for sure it is concave down. Checking the next one, we can see that the slope is going in the negative direction here. It zeroes out, and then it goes up this way. So it's going in the positive direction, meaning that it's concave up. This next one, let's draw our arrows from here and then until here. We have concave down like this. And we can see that the slope is going in the positive direction here. It zeroes out here, and then it goes in the negative direction here. So for concave down, we're going to have this U right here, and that really just says that from this region and this region, we have concave down. That's what the U does. So this U in simple terms. So this U, and then we have a parenthesis, we're going to have the value 0, and then it goes until 10. So this is our concave down, and this is concave up. Now for inflection points are actually these points. And what inflection points are, is they're the change in concavity. So when it goes from concave down to concave up, we have an inflection point. Well, if we look at a graph, we have an inflection point right here. It changes concavity. And we also have an inflection point right here. So that means our inflection points are going to be when x is equal to -6 and when x is equal to 0. And that is how we would look at concavity just given a graph.